I'm showing you already. I written some pre-content so that I can save time. Okay, no, first we'll begin like this here. So this is the position versus time graph. A particle, an object is moving along a straight line. Then its position versus time graph is as shown. Then what do its interpretation? That object is what I'm showing a person. This will be more practical thing is what you can feel about this particular graph here. A person moving along a straight line, its position versus time graph is as shown. Then we are going to interpret it. So what all we can find out from this. So look at this on y-axis, we have a position. On the x-axis, we have a time. Then first there'll be a displacement of person. For 2 seconds, you'll have a displacement of 4 meters. Then for another 4 seconds, from 2 to 6 seconds, you will not undergo any displacement. Is there at 4 meter only because there's a position. Then for another 1 second, you will return back to the original position. You'll come back to the origin. You'll come back to the initial point. Then you'll start moving towards left. By how much of distance? 2 meters. Then for another 2 seconds, it will not move. It will be there only. So what is actually the path? This is a graph. Okay, everyone knows. So this is the path. You should come for this one. This is very, very essential for us. What do you mean by path? You yourself, you are standing here at t equals 0. Then you are going to walk for 4 meters in 2 seconds. Then for next 4 seconds, you will not move. You'll be at rest. Are you seeing this? Position will not change. So 2 seconds. Next for 3, 4, 5, 6. For another 4 seconds, you'll be at rest. You'll not move. Then in 1 second, you'll start moving back. 6 seconds got over. In 1 second, what when you'll come back to the initial point. You are at initial position now. So what is the displacement? Will be 0. For 7 seconds, displacement is 0, no? Plus 4 minus 4. Then for another 2 seconds, you will walk 2 meters towards left. And there, what will happen for you? You are going to stay for another 2 seconds. You'll be at rest. You'll not move. What is the total journey? I will just say that for 11 seconds, we are describing motion. So what is the total distance covered? Total distance covered will be plus 4, plus 4, plus 2. So how much shall I write? $10 meters. What about the total displacement? He was initially here, no? And finally he has come here. So the displacement you're going to measure towards left. So therefore this will become minus 2 I cap meter. What about average speed for 11 seconds? Distance covered by time taken, 10 by 11. What about average velocity? Displacement by time taken. Okay, I think fine. So we are able to predict so many things here. The path will be like this. First, he will move along positive x-axis, then he will return back, then he will walk under 2 meters. This for the motion that takes place here. What about its velocity versus time graph? Okay, this is about something. Okay, let's do one thing. If I calculate the slope, here, what do I in position versus time graph? If I calculate slope, what do I get? I think I'm discussing position. Yeah, let that be displayed. In position versus time graph, if I calculate slope, I get the velocity. And look at the slope of this constant. And how much of slope is 2 meters? So slope constant 2 meters. Then there's no displacement. Okay. Now the slope in a position versus time graph will give the velocity. Then what is the slope here? It is equal to 4 minus 0 by 2. 4 minus 0 by 2 minus 0. So the slope is 2 meters per second. I think everyone knows. And what is the slope of this will be 2. Then here, what is the slope will be 0. So in VT, so what is the velocity equal to ds by dt, or slope in ST graph? There's a basic idea is what I'm applying here. Please use it here. Huh? Then, okay, next again for 6 to 7 seconds. What the slope? Slope is negative, no? Here, how do we can calculate? So we'll do one thing. Can we calculate all those slopes? Yes, we can calculate. I'll go for the calculation part. Slope will be V02 will be 4 minus 0, 2 minus 0, 2 meter per second. Slope for V2 6. V2 6 will be 4 minus 4 by 6 minus 2 will be 0. Speed of particle from 6 to 7. Speed of particle from 6 to 7. What is the slope? Slope will be the position is 0 minus 4 by 7 minus 6 will be minus 4. The slope for 7 to 9 will calculate. Where looking at this curve, I'm calculating. So what is the velocity? Velocity will be, the position of particle will be minus 2, minus 0 by 9 minus 7. Oh, you are getting now why I'm writing 2. What is the slope? 2 meters. For 0 to 2 seconds, uniform velocity.